Okay, let's talk about the slopes of lines in planes. Now, in order to talk about the slopes of lines, what we are going to need is we're going to need 2 points in the plane. So we'll start with the first point. We'll call it x1, y1, which is the x value from point 1 and the y value from point 1. And then we'll add a second point, x2, y2, same concept. Second point's x value, second point's y value. Let's zoom in on this first quadrant. So we have these 2 points in the plane, and we can connect them with a line segment. So that line segment has a slope or a slant associated with it that's going to describe the steepness of that segment. The 2 parts are going to be the vertical change, which we call rise. Now, to find the rise, delta y, we just simply take the second point's y value, y2, and subtract from it the first point's y value, y1. So rise is y2 minus y1. It'll tell you the vertical change from one point to the next. Then we look at the horizontal change, which we call run, or delta x. So in order to find the run, we take the x value of the second point and subtract from it the x value of the first point. So x2 minus x1. The slope of this line is simply the ratio of its rise to its run. That would give you the idea of how steep the line is. The bigger number you get for rise, the steeper the line is gonna be. And the smaller number for run is going to be the same thing. But this is the slope of the line containing those 2 points. So you have a line extending beyond those 2 points in both directions that contains the line segment between them. And the slope of that line is the constant ratio of rise to run from one point to the next. So this ratio of rise to run is going to be the same for any 2 points on the line. It doesn't matter which 2 points, you're going to get a proportional ratio. All right, so let's go ahead and try to find the slope of a line. Here we have a line, and in order to find the slope, I have to identify at least 2 points on the line. So I'm going to identify 2 points that I can clearly see the x and y value. So here I have this point up back here, -2, 1, and this point here, 3, -1. Those meet at a lattice point of the rectangular coordinate system. And in order to figure out what the slope is, I'm going to go from the point furthest to the left and see how far I have to rise and run to get to the point on the right. So the rise, well, I'm going to rise -2, which is down to 2 in the negative y direction. And I'm going to run 5 from that point. So rise is -2, run is +5. And that's going to be my rise and run. So I can form the slope. The slope is just -2 over 5, which is rise over run. All right. Let's take a look at another line. Here we have another line. This type of line is called a horizontal line. Horizontal line. So let's go ahead and try to find the slope. We just need 2 points that are on the line. So here I have 2 points, -2, -2, and 2, -2. So first I'm going to find out how far I have to rise to go from one point to the next. But in this case, there's no rise because the 2 points are at the same altitude, on the same level. So the rise is 0. On the other hand, from one point to the next, I would run, it looks like 4 units. So run is 4. And there I can find the slope now, rise over run, which is going to be 0 over 4. If you put this into a calculator, 0 divided by 4, it'll tell you that that slope is 0. And since slope measures steepness, that means that the steepness of this line is 0. All right, now let's take a look at another line. This is a vertical line. So a vertical line. All right, let's find the slope of this vertical line. So we need 2 points on the line. So let me see, we got 1, -1 as one point and 1, 2 as another point. So first I'll look at the rise. And it looks like from here I'm going up 1, 2, 3. So the rise is 3. But the run to go from one point to the next, I don't have to go left or right at all. Therefore, the run is 0. And now I can find the slope as rise over run, rise divided by run. So the slope is 3 divided by 0. If you type this into a calculator, 3 divided by 0, the calculator will give you an error because this fraction is undefined. You cannot divide by 0. All right, now let's use that formula that we found earlier to find the slope of a line. This formula here says the slope of a line containing points x1, y1, and x2, y2 is equal to this formula here. So instead of being given a graph, we're just being given the two ordered pairs without any visual. So we're just going to use the formula in that case. We need to identify x1 and y1, x2 and y2, but those just come from the two ordered pairs. So this is x1, this is y1, this is x2, and this is y2. So let's identify those formally. Once we've identified those, we just plug them into the formula. So it's going to be y2, which is -5, minus y1, which is 3. So -5 minus 3 is the numerator. In the denominator is going to be x2, which is 6, minus x1, which is -4, 6 minus -4. Well, -5 minus 3 is -8, and 6 minus -4 is actually 6 plus 4, or 10. So we get -8 over 10. But you do have to reduce your fraction here. They both have a common factor of 2, so if I divide the top and bottom both by 2, I'll get -5 over 4 here. So the slope of the line connecting -4, 3 and 6, -5 is -4/5. -4/5. All right. So let's go ahead and take a look at a scenario where we have the point 0b being on the graph of a line and also the arbitrary point xy. So 0b is what we call the y-intercept because it's on the y-axis. So basically this is an equation that we're going to come up with, or we're going to find the slope of this line given the y-intercept and a generic point xy, any random xy point. So m equals y minus b, which is y2 minus y1. Remember, the numerator is rise, which is just y2, the second y value, minus y1, the first y value. And then we're going to divide that by x2 minus x1, which in this case is x minus 0. So this is just the formula for the slope, y2 minus y1 over x2 minus x1. But x minus 0 is just x. And I'm just going to go ahead and solve this equation for y and see what I get. So to solve for y, I need to get rid of the fractions. So I'm going to multiply both sides by x. Multiplying both sides of the equation by x. So x times m on the left, x times y minus b over x on the right. The multiplication and the division by x will cancel on the right side. So those cancel out, leaving me just m times x is equal to y minus b. And then last, I'm just going to add b to both sides. So when I add b to both sides, I get this. Y is equal to m times x plus b. You might recognize this. This is the slope-intercept form of an equation of a line. Now, specifically, in order to use this, one of the points you have to have is the y-intercept, 0b. But if you have that point 0b, then this will give you the equation of a line. Y equals m, the slope, times x plus b. All right. So let's go ahead and use this to find the slope and y-intercept of a line by putting a line in this form. So this is the slope-intercept form of a linear equation. So here we're going to identify the slope and y-intercept of this line. I know it's a line because it's in standard form of a linear equation, ax plus by equals c, where a is 5, b is -3, and c is 12. In order to find the slope and y-intercept like they're asking me for, I'm going to first put it in slope-intercept form. To do that, I have to solve for y. So to put the equation in slope-intercept, solve for y by subtracting 5 from both sides. So I subtract 5x from both sides, I should say. When I subtract 5x from both sides, the left side, they'll cancel, leaving just negative 3y. And on the right side, those are not like terms. So all I can do is list them, negative 5x and plus 12. I can't combine them. Then I'm just going to divide both sides by negative 3 to get y all by itself. So divide both sides by negative 3. Divide left by negative 3. Divide right by negative 3. Well, negative 3 divided by negative 3 is just going to cancel over on the left side, leaving just y. Then I'm going to have negative 5 divided by negative 3 and 12 divided by negative 3. Well, negative divided by negative is going to be positive 5/3, and positive 12 divided by negative 3 is minus 4. So this becomes y equals 5 over 3 times x minus 4. This is slope-intercept form of this original equation. But when it's in slope-intercept form, I can identify the slope and y-intercept. So y equals m. M is the slope, 5/3, times x plus b. B is the y-intercept. Well, b is actually the y value of the y-intercept. The y-intercept is actually the ordered pair where x is 0 and y is negative 4. So this is how you can use the equation of a line to find the slope and y-intercept. You can't do it if the line is in standard form, but it's relatively easy when the line is in slope-intercept form. All right, now let's go ahead and define parallel lines. So two lines that have the same slope and different y-intercepts are called parallel lines. Parallel lines never intersect because they have the same steepness. They're increasing at the same rate. So when we have parallel lines, we know that the slope of one line is equal to the slope of the other. Here's a situation. We want to determine if the line that has the equation 14x minus 6y equals 17 and the line that has the equation 7x minus 3y equals 9 are parallel to each other, perpendicular to each other, or if neither of those things are true. Well, first thing we need to do is we need to find the slope of each line by solving each equation for y. So to solve this equation for y, I first subtract 14x from both sides. The 14x's will cancel, leaving me just negative 6y on the left, and then negative 14x plus 17 on the right. Once you have this now, the last step is to divide both sides by negative 6. So I divide both sides by negative 6. Negative 6 divided by negative 6 on the left is just going to leave y, 1y. And on the right side, negative 14 divided by negative 6 is positive. Negative divided by negative is positive. And positive 17 divided by negative 6 is just negative 17 over 6 because positive divided by negative makes negative. So this is the slope-intercept form of the equation. I don't need to know the y-intercept, which would be 0, negative 17 over 6. All I really need to know is the slope, which is the coefficient of x here, 14 over 6. But 14 over 6 we can reduce because 2 goes into 14 7 times and 2 goes into 6 3 times. So the slope of this line is 7 over 3. All right, let's do the same for the other line. So here's the equation, 7x minus 3y is equal to 9. First, I'm going to subtract 7x from both sides. They'll cancel on the left side, leaving just negative 3y. On the right side, I'll get negative 7x plus 9. All right. Then the last step now is to just divide both sides by negative 3 to get y by itself. Negative 3 divided by negative 3 just leaves me y on the left. And then negative 7x over negative 3 gives me positive 7/3 because negative divided by negative is positive. And then 9 divided by negative 3, that's negative 9 over 3, which is just negative 3. So I have the slope of the second equation to also be 7 over 3. And remember, parallel lines are lines that have the same slopes but different y-intercepts. These two equations are lines that have the same slope, 7 over 3, but different y-intercepts. So that is how we find out if two lines are parallel to each other. So I say these two lines are parallel because they have the same slope. The other thing we could have found is that, or the other two things is that these lines are either perpendicular or neither of those things are true. Let's define what perpendicular means. So two lines are perpendicular if they're in the same plane and one of their slopes is the reciprocal of the opposite of the other's slope. So the reciprocal of the opposite of the other one's slope. So that means one slope, m1, is equal to the reciprocal 1 divided by the slope of the opposite of m2. So not only am I flipping the fraction over, 1 over the slope, but I'm also making it negative, reciprocal and opposite. Okay, so let's take a look at this one here. So we're going to determine whether these lines are parallel, perpendicular, or neither. So first we're going to find the slope of this one by solving it for x. So I subtract 2x from both sides. The 2x's are going to cancel on the left, leaving just 5y is equal to negative 2x plus 10. Then I'm going to divide both sides by negative 5. It leaves me with the equation y equals negative 2 over 5x plus 10 over 5, where 10 over 5 is just 2. So the equation of the first line is negative 2 over 5. So that means in order for these two lines to be perpendicular, the slope of the second one would have to be the opposite of this. So instead of a negative, it would have to be a positive. And it would also have to be reciprocal. So instead of 2 over 5, it would have to be 5 over 2. So if they are perpendicular, the slope of the other one would be positive 5 over 2. Let's see. So we take the equation. First, we're going to subtract 5x from both sides. That's going to leave me with 2y is equal to negative 5x plus 6. Then we're going to divide both sides by negative 2. The negative 2's are going to cancel on the left. I'm going to get y is equal to 5 over 2x minus 6 over 2. But 6 over 2 is just 3. And then we get the slope of that second line to be positive 5 over 2. So one of them is negative 2 over 5. And the other one is positive 5 over 2. So not only are they opposites because one is negative and the other one is positive, but they're also reciprocal because one is 2 over 5 and the other one is 5 over 2. Because they're opposites and reciprocal, these two lines are perpendicular to each other. Two perpendicular lines.